Prehistory changed in Denali on June 27, 2005. In coarse sandstone at the edge of Igloo Creek, a field camp student discovered the footprint of a theropod, a three-toed, 200-pound carnivore that walked on its hind legs during the Cretaceous period, 65 to 70 million years ago. Fran Manella, director of the National Park Service at the time, happened to be on hand in Alaska as researchers secured and carried the fossil from the field.
Here you go.
Look at this thing, it's for real.
Yeah.
Oh my God.
You don't get them much nicer than that.
I had no idea.
Since that day, many hundreds of tracks have been found at more than 20 sites throughout the park. Some areas are so littered with dinosaur footprints that researchers call them Cretaceous dance floors. There is mounting evidence of additional dinosaur species, as well as an array of prehistoric fish, wading birds, and insects. Within a few short years, Denali is coming to be known as one of the premier places in the national park system to study a complete fossil story of the Cretaceous environment. At the conclusion of the 2008 field season, Anthony Fiorillo, a paleontologist who has been leading the research here, answered some of the most common questions about the presence of dinosaurs at a time when Mount McKinley and the Alaska Range had just barely begun to rise from a layer of rock below the ocean floor.
Tyrannosaurus rex is a theropod dinosaur, and a theropod dinosaur is an animal that ate meat. Quite simply, it's usually a bipedal, ran on two legs, and it had sharp, pointy teeth, and it ate either fish or other dinosaurs. Theropods are, as a general group, they include a variety of meat-eating dinosaurs, and Tyrannosaurus rex is perhaps the most famous of all the theropod dinosaurs. A hadrosaur is a plant-eating dinosaur. It's commonly called a duck-billed dinosaur, and they had a unusual flattening of the front of their mouth, which gave them the general appearance of a duckbill, hence the duck-billed dinosaur. They walked on their hind legs, and some of the hadrosaurs actually achieved body lengths of 35 to almost 40 feet in length. So they're pretty good sized. They're very popular. They evolved in what we call the Cretaceous, and they're probably the most common dinosaur during that window of time, at least in North America. They're not found everywhere, but in North America, they're sometimes referred to, they were so common, they're sometimes referred to as the cows of the Cretaceous. The dinosaurs of Alaska, that's a great question, because did they live here year-round or did they migrate, is the question that's been burning since the first remains were ever found. And there are some people that have argued that they migrated. During the wintertime, they moved several thousands of kilometers to the lower latitudes to forage and do whatever animals needed to do. I personally, after studying the bones of dinosaurs on the North Slope, think that these dinosaurs lived here year-round, which opens up a whole variety of very interesting biological questions. The key one being, how did they make it through the year? What did they do during that time when the sun wasn't out and bright and shiny? What did they do when the trees dropped their leaves? And those are some of the questions that we still don't know the answers to. That's another great question. If they lived here year-round, what were the adaptations that they might have had to survive through an annual cycle? And so far, we haven't seen any definitive adaptation other than in one small meat-eating dinosaur. That animal is called Troodon, and it's a two-legged dinosaur that's really quite rare throughout North America in the lower latitudes. However, it's small, it's about 6 feet long, ran around on hind legs. Here in Alaska, here on the North Slope where the bones are from, it's actually very abundant. It's about 3/4 of all the theropod dinosaur remains we find. Why is that? Well, the one thing that distinguishes Troodon from the other small meat-eating dinosaurs is that Troodon has the largest diameter orbit of any meat-eating of any dinosaur compared to body size. And so if you think about the difference between hawks and owls, for example, when are hawks active? When are owls active? And what is a distinguishing character of an owl? Well, they have really big eyes. So we think that Troodon may have been adapted for life here in the north. That it wasn't an adaptation for the north, but it was an adaptation that evolved so that during dawn and dusk it was the dominant predator, but here in Alaska it found pay dirt, and that was where it thrived. There are mammals that are around when dinosaurs were around. Generally, they were opossum-sized or smaller, and we know that some of those mammals lived in Alaska based on the teeth that we've and some bones that we've found up in the northern part of the state. However, here in Denali, we've not found evidence of mammals, but it's probably more a function of we're still beginning our study rather than we can say they weren't here. As far as birds, birds are here in Denali because we have an incredibly rich fossil bird track assemblage. We have sparrow-sized birds. We have birds probably the size of willets and avocets. And we also have birds that their footprints are big enough that they'd be twice the size of a sandhill crane. So we have quite an abundance of bird tracks here. Probably the biggest reason is we're just beginning our study. I think, based on everything I've seen to this point, that with time we will find bone material here. One of the things to bear in mind, though, is that one animal makes a lot of tracks during the course of its lifetime. And so, just based on probability, it's more likely we're going to find the tracks of an animal rather than the bones of an animal. But based on everything I've seen, I think over time we will ultimately find bones here. A lot of times people look at the footprint here at the visitor center and wonder why is it raised as opposed to a depression, because everybody makes footprints, they've seen that they're depressed. The track is raised because the actual footprint has been eroded away. So an animal pushes its foot down, leaves a depression that gets filled in. Then the whole thing becomes hardened, turns to rock, gets uplifted, the footprint gets eroded away, and so what you're seeing is the infilling of the footprint. So you're seeing that rather than the actual track. Dinosaurs basically are into two categories. There's meat eaters and plant eaters. More specific than that, we can't get at right now. I mean, meat, based on the wear patterns on teeth, and looking at what we call micro-wear patterns of teeth, the wear patterns are consistent across all the meat-eating dinosaurs. So we're not, and they show evidence of a fine wear pattern, which suggests to me that they were all eating meat, as opposed to some were eating meat and some were crunching up bones. We don't seem to have any hyenas within the dinosaurian world. They seem to have all eaten the meat or swallowed the bones whole. And when you think about it, you know, you have a big dinosaur that's swallowing a big meat-eating dinosaur. It could easily swallow some toe bones without too much difficulty. Plant eaters, we can tell that the horned dinosaurs, for example, were eating coarser food items than the duck-billed dinosaurs, because the wear on horned dinosaurs is much coarser. There's a heavy scratching versus the finer scratching of duckbills. But they were all eating plants, but we can't tell specifically which of those plants they were eating. I don't care. You know, the question is more interesting to me. I'm not a physiologist, and the question isn't so much to me whether they were warm or cold-blooded. It's what was their level of activity. And modern animals do a variety of things, and it's pretty much independent of whether they were warm-blooded or cold-blooded. Now, there are people who have argued very strongly that they were warm-blooded, but there's also evidence that they were cold-blooded. So I don't worry so much about that so much as what I can glean about the behavior of the animal. Yes, the climate seems to have been different. We think, based on a variety of information, basically gleaned from fossil plants and some of the fossil invertebrates, that the climate here in Denali some 65 to 70 million years ago was significantly warmer than it is now. What does significantly warmer mean? We think that it was the mean annual temperature was on par with southern Canada and perhaps northern lower 48 US. And so that's what we think the climate was like here. The bottom line is, if you find fossils in any national park, they're the property of the US government. And that's for the betterment of our understanding, because then it's accessible to everyone.